going to show you how to do a two-way ANOVA using Excel. First, we're going to look at the data here. This is a two-way ANOVA because we have two factors here represented in the data. We have age and we have gender. And it asks us, this question asks us whether or not pulse rates are affected by an interaction between those two, between gender and age, and if pulse rates are affected by just one factor at a time, age alone and then gender alone. So let's pull up Excel, and what we're going to do is recreate this table in Excel. I think that's easier than copying it to StatCrunch and rearranging it that way. So we're going to type in the categories here, these factors. And we'll start typing in our data. And now we'll put in this data here, the 60, 92, 81. Okay, to speed this along, I'm going to show you the finished product. There's all of our data, recreating this table here. We're going to go to the Data tab, and you need to make sure that your tool pack is installed. But go to Data Analysis, and we're going to do two-factor with replication. And then we're going to select our data, our input range. You need to make sure that when you select your input range that you're also selecting the labels themselves. Rows per sample. Your row variables are your sample variables, and so you have 1, 2, 3, 4 rows per sample. The significance level is 0.05, just like it states in the problem. The output range, you want to just select a cell down below your table. So down here, that's fine for your output range. And then click OK. Once you do, it does all the analysis for you. And then down here is where we see the results of that, that analysis of variance. One of the first things that asks us for is the interaction between age and gender. And that's displayed here in this line. Again, it gives us our F statistic, and it also calculates F critical for us. The null hypothesis is that there's no interaction between age and gender. And we want to see whether or not we reject or fail to reject that null hypothesis. Because the F statistic is so much smaller than the critical value, we're going to fail to reject that null hypothesis. And our p-value is very large compared to the 0.05 significance level. So that leads us to the same conclusion, that we are failing to reject our null, which means we would say that there's no interaction at all between, well, there's no significant interaction between age and gender. So here for a choice, we would say since the p-value is greater than 0.05, there's no significant interaction. Now let's look and see if pulse rates are affected by gender. So gender is in the rows, and that's labeled as our sample. So if we come and look at our sample, again, our F statistic is smaller than our critical value. Another way to look at this is to look at the p-value. The p-value here, 0.60, is larger than the significance level 0.05. So we're going to fail to reject the null hypothesis, which means we will retain the null hypothesis, which is that there's no interaction, there's no effect from the row variable, which is your gender. So we're saying gender has no effect because the p-value is large. So p-value is large, rates are not affected by gender. And finally, we'll look at we'll look at age and see if that has an effect on pulse rates. And age is in our columns, so we're going to look at the column output right here. We see we have an F statistic again, that is smaller than the critical value, and a p-value that is large compared to the significance value. So again, we're going to fail to reject our null, meaning that there is no, the age doesn't affect our pulse rates either. And so we'll come over here and say, since the p-value is large, rates are not, p-value is large, rates are not affected by age. Okay, hopefully that helps you use Excel to do this last problem and calculate that ANOVA using some technology.